Hello and welcome to Console Cowboys. So if you watched the last video, which was the overview of this code, and you understood it and you played with it and it all makes sense, then you don't need to watch this video. So like and add a comment letting me know that I saved you some time and if you liked the last video. And if you didn't understand it or you're new to Python, this is your video. So we're going to go over the syntax of Python, how to develop these tools, go line by line through the code, and explain it a little more in depth as a learning opportunity on how to code real scripts and real tools, not just hello world. In this case, we're going to talk to the blockchain and we're going to grab transactions down. We're going to analyze these transactions for certain factors so that we can find non-human activity on the blockchain, specifically looking for stuff like front-running attacks and sandwich attacks. We can do this with simple Python code and get a lot done. Now, in order to see what that looks like on the blockchain, this is what we're looking for. We're looking for an address that is running a lot of transactions. This is 129,000 transactions. Generally, this is not going to be a user. This is going to be a bot. In this case, everything's going to this MEV bot, which I think they just had a huge hack yesterday, but whatever. Not going to get into that. Now, you'll also notice there's 67 and 67, so that's the block number, and there's two transactions in there, both to and from the same place. 16 minutes ago, 99 and 99, two going to the same place, and you'll see this pattern repeated over and over again. The reason being, it's a sandwich attack. They're posting a transaction at a lower amount, a bigger order is going through, which raises the price, and then they sell and they make a profit all within the same block by adjusting their gas fees. Easy peasy. Now we're going to look for this particular pattern, and then we can analyze these further. Because this is the Forensics series, so we're going to look at all of this data and try to make sense of things. Now, in order to do this, we're going to need to import Web3, because that's how we talk to the blockchain. So from Web3, import Web3, and then we can use that Web3 import to talk to the blockchain through an Infura node. If you need to install that, pretty easy. All you do is a pip install Web3 at the command line. You're probably going to need a sudo because you're going to get rights issues, or you can use, env and install it into there. It's up to you. But all you do is a sudo pip install, and then you can check it right on the command line by just typing Python 3. It'll drop you to the little Python terminal. If you type in the same thing from your program and you get 0 errors, that means you're good to go. And then just exit out of there. Now, what are we going to do in this program? Well, we need to set up our variables that hold things like our to and from variables. So within each of these transactions, so here's a transaction, you're going to have the transaction hash, which signifies this is the transaction we're dealing with. You can look up the transaction with that hash. And you have your to and from. And as we just talked about, we need to find blocks that have multiple to from pairs in the same block, because blocks happen every 15 seconds. Likely if there's multiple in a block, it's not going to be a user, it's going to be automated. So with those variables, we need to fill them up with data, and that's what we're going to do within our main code block. So what we're going to do is grab transaction hashes, and with those transaction hashes, we can look up the values in the transactions. And then once we have those transactions, we can look at our to and from addresses. We can create a pair dictionary with those of to from values. And if they already exist in our database, meaning we saw them in another transaction, we can update the count in our transaction count and just say, oh, we already saw that, let's just add 1 and make it 2. So pretty easy. So that's what's going to happen within the main code block. We're going to log the to from values within one single block, and we're going to increment and see how many times those to froms actually show up. And then we want to print things out at the end and say, okay, well, if we saw exactly 2 transactions in a single block that have the same to from values, let's print out one of those addresses and take a look for closer manual review to see what that bot is doing. In our case, we're looking for those sandwich attacks. So let's hop in and actually do some coding. So you saw above, we have our Web3 import. So with our Web3 import, we need to make use of that. What we're going to do is we're going to have an HTTP Infura URL that gives us access to the blockchain, and then we can reference that with a Web3 variable that we create. Now we're doing this with the Web3 we imported, so we'll say Web3 HTTP provider, and we want to put our URL in there. If you've seen the ethers.js or the web3.js, you know what this is. If you haven't, I'll quickly show you here. So if you create an account on infura.io, then you create a project, you'll have something like this here. And if you go to manage key, you have right here your Ethereum mainnet key, and you can just copy that and paste that URL in here. Once you paste that URL in here, you have a connection to the blockchain using Web3. Now, what do we first want to do with that connection? Well, let's grab the blocks off the blockchain. So we could say block equals web3.eth get block. And what do we want? We want the latest block. So pretty easy. We're just using that Web3 variable we just created. We're saying use our connection to the blockchain to grab the latest block, and we'll assign that to a block variable that we can use to look at all the data. Now, before we get rolling into the main code, there are two other variables we want to create, and these are dictionaries. What is a dictionary in Python? If you haven't seen it before, because I don't think I've used dictionaries in our previous coding tutorials, it's pretty easy. It's just a key value pair. So you could say, okay, favorite fruit, apple. Now, every time somebody looks up favorite fruit, they're going to get the value apple back. And that's really all it is. And what we're going to do on the blockchain with it is we're going to log some pairs. We're going to say we want to log the to and the from each transaction, and keep a catalog of each transaction had this to variable and this from variable. And then we want to check if those already exist in the database. And if they do, we're going to log the to, and we're going to say 1. Okay, we saw it once. If we see that same exact pair together again, it'll be 2, 3, etc. And what you saw from our sandwich attack is that, we want to find blocks with 2 of those pairs in the block that are running that sandwich attack. So those are what dictionaries are, and that's how we're going to use them. First thing that we're going to do is we're going to grab the blocks and grab the transactions back. So what we're going to do here is hop into the main code block. And the first thing that we're going to do is we're going to say if that block variable came back okay, and that block actually has transactions, we're going to loop through each of the transactions with, okay, block.transactions. For every transaction, we'll name it transaction, and we'll loop through until there's no transactions left. So it'll go beginning to end and loop through every single transaction in that block. Pretty easy. And then once we do that, we want to do some stuff. So from that block, we actually need to look at that transaction data. So we're going to grab the transaction hash, and we can do that by saying transaction.hex, and that will convert from hex bytes to the format that we want and store that in a transaction hash variable. We can use that transaction hash to actually get the transaction and assign it to the variable tx. Now with that tx variable, we can print out all the data in the transaction. Pretty cool. So just to give you the visual of that, if we hop back in here, here's our transaction hash, which references this transaction. If we submit that transaction hash, like paste it up in here, we get this transaction, we can see all the data. And that is all we are doing right here in code. We're grabbing the transaction hash, we're submitting it to get transaction, we get the data back in this tx variable, and we can parse out that variable and get info. So what I will propose here now is let's, at this point, just print out these transactions. So we can do it with a Python statement, right? Print, and we'll say tx, and we'll see what comes back. We should get all the transactions. So if we hop back into the terminal, I'd name that find bots. So we'll go Python 3 find bots. And we got, oh, I'm missing my Infura URL. So I'm going to pause this. I'm going to put my Infura URL in there, and then we will run it again. All right, I have pasted my Infura URL in there, so it should work this time. All right, so now we're scrolling all the transactions in the block. We could see block hash, and here's the hex bytes of that, right? That's why we had to convert it. we have our chain ID, we have our from, we have our gas price. So all of that data in the transaction is there, and now we can start parsing that out. So let's do that. We are going to paste in the rest. We can get rid of this print statement. We don't care about printing them out anymore. We just want to do stuff with it. So I'm going to paste in these two if statements. This is our core functionality in this application. It's not that complicated, but it does have a couple nested if statements and an else statement, and we'll roll through and talk about those. At a very high level, it's really checking that the to value and the from value, if they already exist within the databases we created up here that are currently empty, then it will update the count. But if it doesn't exist, then it will create those. So the first time through, this transaction doesn't exist because our databases are empty up here. So it's going to skip this. It's going to say, oh, tx.to, is it in our to from pairs? Well, it's not. So we're going to say, okay, if tx2 not in our to from pairs, so our to address is not in there, we're going to update the count. So we'll say, well, here's our to address, whatever that address is, and then we give it a value of 1 right here. So tx2 equals 1. We update the database, and then we say, okay, well, our to from pairs database, we need to log those to and those from values. So we have a running log of those. So we say to : from. And if we call the to, we always get back the from. If we call the to here, we always get back whatever the count is, right? So the first time through, those were empty, so we had to add them. And then maybe the second time through, the next transaction in the block, we go through and it's the same situation again. So now we're going to do it again. We're going to say, okay, well, we have a new to from, and these are just different values because a different transaction. And we say, oh, here's the new address. And this is also set to 1, right? And then we go through a bunch of transactions and we eventually find one that does exist. So we hop down in here and we say, okay, this to exists in our to from pairs database. Okay, cool. Well, let's check, does this to actually have the same from the blockchain as well? And we go, okay, well, this to, here's the from value. Oh yeah, that equals as well. So this to from pair actually exists in the to from pairs database. So we'll update our count. And then when we do that, we say the transaction count of our value equals the transaction count of our value plus 1. So what happens here is, okay, this existed already, so we're going to add 2 to it. And then if we went through a bunch of transactions more and we saw another one where it was the same to and the same from values in our database as was in the new transaction, we'll say, okay, there's 3 of these now. And that's how this actually works here. And the only other thing I didn't explain is right here, we're just doing some error checking, and we're checking if the transaction's to value does not equal none, meaning it's not empty, because if we try to process an empty value, it'll blow up. I saw somebody else on the internet doing that somewhere. So I was like, okay, if they had an issue with that, an issue can crop up in our program too. So let's just do the error checking so we don't run into issues. Now that we have this, we can actually see this working, and we could take a look at the values in action on the blockchain with this, by just saying print, and what we want to put in there is our to from pairs as well as our count. So we want to print out our count too. So we'll say print transaction count, and then we need to make sure, we fix our issue up here where we filled that in with random data. I'm going to have to put my Infura URL in there again, so 1 second. All right, now that we have our Infura URL in there, let's run this and see what happens. What we should get this time, instead of all the scrolling transactions, we should just see the database of our to from pairs and then our database of our counts. All right, so here are all of our addresses, right? Scroll all the way up here. So you'll see here's an address and then :1, 11111. So each of these has 1. Oh, and then here's one with 2. So this one saw it had exactly 2. So that could be one of our bots. And we scroll down. Here's the next list we created, which is the to from pair. So we have our to value, our from value, our to value, our from value. and then our counts for every one that it saw down here. So that's all of our data. But again, this is a lot of data, so we want to parse this out and make more sense of it. So let's take a look at that. So back in our code, instead of printing all of that out, let's make our decisions here about what we want. So we're going to say for key value in transaction count dot items. So this is how to cycle through a dictionary, and we'll get the key and the value, and we can use both of these values within our logic. So we're just going to say, here's our transaction count dictionary. We want all of the items. And then once we get all the items, we want to assign them to our value and to our key, right? The to and the from variables that come out of there. So once we do that, we can do something with it. So we're going to say, well, if the value, which would be the from, equals 2, right? We saw that twice. Let's print those out. And we'll say print 2 from pairs. And what do we want to use? We want to use the key, right? So we use the key to access the value, right? So if we have 2 and from, if we call the 2, which is the key, it's going to give us back the from, and the from will be the contract that is used to do the sandwich attack. So now that we have that, we can print those out. Now let's run that, and we should get a lot less back this time. So we got 1 back, and this one we'll check out here. Say copy. We'll hop into Etherscan. And in here we see we have 3.62 Ether. And it looks like it's going from our address to this, which is probably a contract. Yep, it's a contract. This is probably what they're using to front run. If you wanted to take a look at the code here, you can look at that. It says contract self-destructed, was later reinitialized with new bytecode. So you could try decoding that and taking a look at it. And then if we hop back here, we see 22777. So it looks like there might, if this is a sandwich attack, looks like they might be doing more than one in a block, which is interesting. We should check that out in a minute. We have this one right here, which we flagged on, which is going twice in this 97 block. So let's copy the beginning of this here. We'll take a look and see, is this a sandwich attack? Is this some other bot? Because we have, behavior that's different than 2222. It's still divisible by 2 though. 1, 2, 3, 4, 5, 6. Yeah, so it could be multiple in a block. Never know without looking. So let's check out this block. And we'll look at the transactions in the block, and we're going to search that for the beginning of our thing. Nothing in the first one here. Nothing in the second one. Go to the third page, nothing. Fourth page, nothing. For some reason, these are always in the end of the block, I have noticed. Okay. So yeah, this is looking correct because we have a transaction by the user we found, and then it's going to a Uniswap router of the victim, and then we have another transaction by that person we found. So this should be the buy order at a lower amount. Then the user comes in and buys a larger amount. There's a 1.61 ETH because we're only using a little bit here. And then it comes back and we have a sell-off. So let's check out this. We have swapping 1.1 ETH, 1.10 ETH for 78,000 Okinu coins on Uniswap. Okay, 1.10 for 78. And then our cell should be more than 1.10. So if we look at that, you'll see we did make a profit there over our 1.10. However, we also made a profit on the coin because we only sold 74. So we're winning on both ends. And that's the sandwich attack. Now, there's also some other weird stuff going on. So if we pop that back in there again, let's just look up our address again here. I'm going to copy this again. And I'm kind of curious what's going on with those other ones where we had multiple. So this is 1, 1, 2, 2, so that looks right, 6, 6, 11. But this one has a whole bunch. There's like 4. And then this one, there was even more than that. So I'm kind of curious what those are doing here. So let's just quickly look at it just for curiosity's sake. Because again, I'm doing this live. I don't necessarily know what it's doing. It said unconventional order up there. I'm not really sure what that means either. But let's go on. We don't need to understand all the things to do research. That is the point of research. All right, nothing in the second block or second page. Check this third page, nothing in here. And we'll check this last page. And you know what? It shows all those other transactions, but in the actual block, it's only showing these 2 posted. So I'm kind of wondering if they tried a bunch of things and the other ones failed and they didn't end up in this block. Makes sense? Not 100% sure if that's what happened, but in my mind, that's what I'm rationalizing. And a lot of the research, you make these presumptions based on the data that you're given, right? So again, here, you know, we have this Uniswap V2 in the center, or V3 in the center. So we're probably buying something for a little less and selling it for a little more. So 0.43 Ether, 434 Ether for 725. So we should have more than 0.34 Ether in this one above it. And we do. We sold it for 0.44 and we sold that same 725 again, right? So that's how the sandwich attacks works. And we got kind of lucky on this first one. It only, you know, had this one here. But if we run it again, you know, we might get something random that's not a sandwich attack, but it's some bot doing some random activity. But we did see some unique activity there too, right? We had multiple transactions getting posted within the block, but ended up rejecting some of them, and only the 2 went in there for the sandwich attack. So that's something to think about in our next iteration of our tool. Like, okay, well, I am seeing some other behaviors. Maybe if it's divided by 2, and it exists in the block, maybe we should still look at it. It really depends on your false positives and what you're seeing while you're doing your R&D. And another thought is maybe I need to look at it a little bit closer, because even though it had the same minute variable, maybe it was in a different block and I just passed over that. So you got to look at all the things. But let's quickly just take a look at one of these other random ones and see if it's not a sandwich attack, because guarantee you out of these 4, they're not all sandwich attacks. Maybe one is, or maybe none of them are. But let's take a look. We got lucky the first time. So looks like this has about 11.55 Ether. And then we'll look at this, 7 minutes, 8 minutes, 11, 11, 31, 33. So it doesn't really look like the pattern we were looking for. You know, it does have some stuff that matches up, but a lot of stuff is just not in the same block. So it's probably not a sandwich attack. But we could take a look at the contract that they're calling and get an idea what it actually is. And we could take a look at the transactions in here, as well as, you know, is there code here, or is it just bytecode like the smart contract on the sandwich bot? And no, it actually has source code here. So it looks like we're using Solidity 0.5.1. Note that's much older. So this has been out here for a while, since 2019. And that's a good example. So a lot of people tell me, oh, why are you using, you know, 0.6 or 0.7 or 0.8 when there's a new version? Well, you have to understand the idiosyncrasies of all the different versions, because there are tons of hackable contracts out there, you know, things that are deployed that are much older, because The blockchain is immutable. These things live forever. So you got to understand all of them. So this is a good example, right? This is using old code. Now what you'd want to do from here is just start going through this and looking at it. Okay, it's a ERC20 token that they're making an interface for. Okay, cool. Read all of these functions, see what they're doing. Oh, there's a second contract within this. How are they interacting with each other? We're using safe math to check for overflows, et cetera, et cetera. So what you'd want to do at this point is read through this contract and see what is this BPTC token doing. And this very well may be just a token contract. And we're seeing a lot of transactions in the same block to this because somebody has some kind of automated thing going on. So anyway, we're not going to go through all of these, use this code, try to find some of those sandwich attacks on your own to try to solidify it in your mind. What do these look like on the blockchain? What are these other bots right here? What is each one of these doing? Look at each one and try to determine the use case in your mind of what is this doing? Is this non-human activity? And what are they trying to accomplish here based on looking at it? And it's a good learning experience to try to start understanding how these things work.